Hi, everyone. Welcome back. We have two great speakers from Google Cloud today. We have Megha Saini. She's a tech lead, and Brinda Jeyaraman, principal architect in AI. And they're going to be here sharing their information about the large language models and AI, Vertex AI in Google Cloud. And so thank you so much, Megha and Brinda, for joining us today. I know Brinda is joining us from Singapore. Thank you so much. So before you get started, tell us a little bit about yourself and how you got involved in the field of cloud computing.
All right. So honestly, it was my journey to cloud computing was not planned the way it came out to be. I was back in India and I never had plans to come to US. Until 2007, when I was invited by the American Association of Artificial Intelligence to come to the Stanford University and share some of my research work with the professors and students here. That was a turning point in my career where I got deeply inspired by this place to really pursue my career in AI and data. Fast forward 18 years, I'm back here and I hope to pay back. But that being said, I started off my career as research analyst, really doing a lot of deep dive on market analysis for the Fortune 100 companies. I got opportunity to work in the corporate development teams, doing analysis for the semiconductor supply chain and so on and so forth. I was preparing a lot of the data for the executives mostly. And while doing so, it was not at all a glamorous job. It was just putting together a lot of spreadsheets together, working with Oracle database, MS Access, SQL back in those days. Not much scalable solutions were there. So I was working those and I realized quickly that when we provide this data to our executives, the one thing that they really need is that they want data fast, they want it accurate, and they want a context around the data when they make these decisions. That brought me to think that we need to have some scalable solutions to build these kind of data tools. And so I joined Amazon a few years ago, and over there I was talking to a lot of customers from different industries, media industry, gaming industry, but at the same time, I was also preparing tools for our internal teams, executives, and I got a chance to work on EC2, Redshift, SageMaker, and other services. Fast forward, we ended up preparing a data intelligence platform that put together all of the company's internal data, and that came out to be one of the biggest deployments of the data platform, specifically for operational efficiencies. Fast forward to today, I'm working at Google Cloud, and again, looking forward to build lead data initiatives and build data products that can put together the company's internal data and also enable our executives to take those decisions by bringing the context in place. And given that now I'm in a good spot at Google, I'm looking forward to evolve this journey to go from spreadsheets all the way to preparing agents in some point in future. So that's been my journey. I'll pass on the mic to Brinda, who's my colleague joining from Singapore.
Thanks, Megha. That was a wonderful journey. So, hey everyone. Currently, I'm a principal architect in AI for APAC at Google Cloud. So, my journey started off as a software engineer in 2007, and I was a very successful software engineer and naturally moved into cloud with Hewlett Packard. And back in those days, we didn't have fancy technologies, so AI excited me. And out of passion, I went on to pursue a master's in AI from NUS. And I was able to do a really good job there and secure a gold medal, which got me into multiple AI projects. So a lot of the local companies started to approach me to lead several AI projects within different industries. So I worked across healthcare, manufacturing, joint labs for banks, several joint labs. And my focus has also been finance in some organic way. So thereon, I built several platforms for AI. We went on to defining best practices, and we went on to have a separate team just to lead and understand how AI is working in real world, and also to be able to define best practices for AI. This was back in 2013. And so I was like an early starter in AI. So here I am with Google Cloud now, doing what I do for the top customers in APAC region. and I help them guide and successfully adopt AI at scale. Yeah, so that is me.
Thank you, Brinda. Let's kick off our session. We have a lot of content today, more than what we can cover in the session. That is intentional. So you can go back, refer to these slides, and if you're curious enough, you would like to dive deeper into certain areas, feel free to do that. We'll go over the real world applications, key takeaways, and we'll probably skip some slides in the interest of time. So let's get started. We'll be talking about the current state of healthcare data, and we'll dive deep into the 3 pillars that Google is offering for enabling the journey on healthcare, which is Vertex AI search for healthcare, Vertex AI as a platform, and AI agents. And towards the end, we'll talk about how to really get started with this journey. So talking about the current state of healthcare data, we saw there have been a lot of studies being done on digital experiences for the customers. We are living in an age where I open up my app, I order a cab, and it is here in 10 minutes. Or I open up an app for making payments, and it is done in a few seconds. Or if I have to do a grocery delivery, it comes to my house in like 2 hours. But when it comes to healthcare, the experience is totally different. We are waiting for a long number of days to really get an appointment with a specialized doctor. We are waiting to get our questions answered. And the worst is that we don't get the support right when we need the care support right at the point when we need it. So we've seen that the studies are telling us that about 82% of the patients are now looking to access these services on the mobile devices. What happens behind the scenes of all of these mobile apps? What happens is that we have a huge workforce working towards it. We have a lot of administrative tasks that go in it. We have to file claims. We have to fill up a lot of patient information manually. A lot of patient summaries have to be prepared. And the cost of that is mind-blowing. It's about $750 billion according to McKinsey. $750 billion coming from the healthcare expenditure going into the administrative stuff. That is not sustainable for a very long time. And the last is that when we did the survey for a lot of with a lot of medical practitioners, the key theme that surfaced was that about 1/3 of their week's time is spent on just this administrative stuff. So there's a huge burnout. About 60% of them have said that there is a burnout symptoms and they are ready to quit. That is a state from our system's perspective. But why are we in this state? What is the underlying problem here? The underlying problem is data. One of those problems is data. So imagine we have a patient named Maya who just recovered from the cardiac procedure, and she's managing her diabetes. She's possibly going to the endocrinologist, her general physician, and a cardiologist. Each of them have their own reports, lab results. Each of them have some scanned images, and all of those are sitting across different systems. So we are seeing that Maya's health record is disparated, it's scattered, it's siloed in different systems. There's no way to put it together for a care team to see a 360-degree view of Maya's health. Not just that, if now Maya goes to have a CT scan, an MRI, we're not talking of the high resolution images. This is an entirely different modality of data that we are looking at. We need systems and models that can understand and read this, but also provided a context around these medical images from the doctor's notes to understand what Maya is really going through and what's her procedure and what's her future care recommendation. Now imagine Maya goes to a different city for better facilities. The new hospital is unable to access the EHR records from her previous facility. There is a huge lack of standardizations across these different formats. And these systems are really creating more friction for anybody to really understand a complete longitudinal record of any health of any patient. Not just that, we have an infrastructure and accessibility issue here. What it means is that our hospitals are not well equipped with the infrastructure that can process these high-end resolution images, put together all of this data, and really be able to access the data at the place when they need it, at the time when they need it. Especially in the emergency situations, you want to have this access to the data at your fingertips. And the last, all of the data is very sensitive. The medications being given to Maya, the claims, the insurance details, all of this has to be secured in some system, which is much less prone to risk and cybersecurity. So what should we do now is the question. We apply the principles of generative AI. And there are really two ways to do this. One is we optimize the processes like the administrative processes that we just spoke about, really looking at accelerating the productivity of our healthcare staff. And through that, we transform the experiences that we provide. What it means is that we are now freeing our healthcare staff from all of those repetitive tasks and helping them focus on the areas where it matters the most. Really focusing on the personalized healthcare for each patient. And this is really not just a theory. We have it in place. A lot of medical organizations are implementing these solutions. We have a lot of assistance available to the medical practitioners. We have virtual bots available to the patients for virtual triaging, for a symptom detector, and so on and so forth. So how is Google Cloud helping enable these solutions? There are three pillars: AI-powered search to enable quick access to the information, Vertex AI platform, which is a unified platform to build these solutions, and agents, which transforms the health workflows. So remember, three pillars: search, platform, agents. We will go through these three in detail in a few seconds. But before that, a quick primer on each of this. When it comes to search, we're talking about the Vertex AI search for healthcare. It is a semantic search on the medical data. What it means is that if you were to really do a search on all of the health records, the lab results, clinical notes, this search doesn't really just provide you a keyword result, but essentially it provides you an entire context on the health of the patient. It is accomplished by unifying all of those data sources, structured, unstructured, medical images, others. It supports multimodality because we have Gemini models supporting it. It can support the questions being asked in terms of voice or text. Plus, it has one major component, which is the LLMs that is specifically fine-tuned for healthcare. That is Google's version of the medically tuned LLM called MedLM. And what it does is that when you were to ask a question on diabetes, it doesn't really just give you a keyword search result, but essentially it provides you all the details on if this patient has diabetes, what kind of care has been given, what are the steps, what is the prescription, and everything around that. And not just that, it understands the medical jargon. So any of the drugs related to this category of diabetes will show up in these results. And that's the power of fine-tuning LLMs. And ultimately, we provide a combination of search and this generative AI capabilities. That is really the differentiation factor, because we want to access not just the information available from outside sources, not just the ones that LLMs are trained on, but also the real-time patient information. If there are new prescriptions being ordered, we need to have access to those as well. So when we apply the real-time accessibility and we apply search to all of those data sources, we get a complete 360-degree picture of patients' health. Vertex AI platform. That is a unified platform to build all of your AI applications. Yes, you have a question.
I know you had a few slides back, but I'm probably forgetting what was on that slide at this point. You're presenting us tools, which is great, and capabilities, great, but I've forgotten what core problem these are doing. So you're already telling me about features, and I've forgotten what it is this is for. So who's the user of this would be really helpful. And then what problem are they trying to solve that they're now engaging with these things? That would be really helpful for me. And
Sure,
probably no one else has this confusion, but for me, I forgot your slide from three before.
So we are trying to solve the challenges that we initially saw with data management. That's the primary challenge. There is the data is in siloed systems. It is scattered all over the place. We don't have a mechanism to really bring that together. Talk about different modalities of data. We have text, images, scanned documents, ultrasound images.
But it's not the clinician you're talking about. This is the IT infrastructure is the place that we are.
So the users are both. So we have personas, which are the patients who can leverage these systems because they get a personalized healthcare plans, and also the clinicians who can access this information right away.
So the problem we're going after is the seamless ability to reach data critical to patients.
That's right.
Regardless of where it is. So we're trying to knock down barriers between silos and all those type of things that we used to say about data sets.
That's right. And also offer personalized care to our patients.
Okay, and I haven't gotten there yet, but you have one more to go.
Okay,
Thank you.
sure,
Megha, if I can add here,
sure.
Megha? Okay. So Megha started with a generic view of the healthcare domain. So later you will see specific problems around genomics and several use cases that you will go through also. So feel free to ask your questions, and I just wanted to let you know that we are starting off from the healthcare domain, and we'll show you some specific use cases as well, which is coming your way.
Talking about Vertex AI platform, a couple of things that you'd absolutely deep dive into is model registry, which is essentially a place where we can have different versions of models that are trained. AutoML, for the folks who are not very familiar with data science concepts, they can readily get started. They can build prototypes before they invest further into the deep product development. We have Model Garden, which gives access to about more than 200 models. These are fine-tunable models offered by first-party, third-party, open source. Then we have generative AI capabilities integrated within the platform, meaning we have this platform powered by Gemini 2. And so it accepts the inputs in terms of the audios, videos, text, images. And then the last is the Vertex AI agent builder. Brinda will be going some of these concepts in details, and we'll see those in action a bit. The third is the AI agents. This is really a system, a software system that initiates a task on behalf of humans. This is really the most advanced concept at this point, wherein we're not just talking to an LLM, but essentially empowering the LLM and empowering the software application to take actions on behalf of the user. They have decision-making capabilities, they're autonomous in nature, they have access to multiple tools to make that action happen, and they're working towards a goal to achieve those actions. Plus, they can self-refine. They collect the feedback from the previous actions they've taken, what was the result, and they improve themselves over time. We'll go through this section towards the end of our lecture, but there are a couple of different resources available that you should look into it. One to call out, a couple of those to call out are the Agent Development Kit and the A2A protocol. This is recently released 2 months ago at Google Next. These are essentially the platforms to build these agents. And once we are looking at the multi-agent systems, meaning agents are now interacting with each other, we have certain protocols for really connecting those agents. So you should absolutely deep dive into both of these. So let's look at what is Vertex AI search for healthcare. And we'll take a quick look at a demo. What did we just see? It was Gen AI in action. It was no rocket science. What we really saw, 3 valuable outcomes, which is essentially the nurse was able to get a longitudinal view of patients' health. She was able to pull up patients' notes, lab results, medical history, medications, everything all in one go. She was able to prepare a simplified summary using all of those data. And then she was able to discover that very quickly. And not just patient data, she was able to access the discharge policies, the hospital policies, discharge instructions, latest prescriptions, and everything together. All of these are really enabled by 3 building blocks. The workflows of those 3 building blocks are, first is unifying the structured and unstructured data together underneath. We then apply search capabilities on top of that data. And we give all of those results to MedLM to prepare those summaries. And just by the virtue of this workflow, we see that there is a better patient care being offered. These workflows can be mapped to the 3 offerings, the turnkey solutions by Google Cloud. First is the Healthcare Data Engine, which is a unified end-to-end data platform that unifies the data across many, many different formats, like FHIR, HLV7, DICOM, others. It has the capabilities to prepare the managed pipelines that can help create the FHIR store and store the data in there. The data is then fed to the MedLM models, which are fine-tuned specifically for healthcare. It's a family of models, meaning there are different models that are specific to certain scenarios, like some models are more proficient in creating summaries. Some of them are more proficient in providing medical jargon, simplifying those for the end user. Then we have the most important, Vertex AI search for healthcare. This is essentially applying search to all of the internal data and not just the research publications, but also the patient data being put together. The answers of MedLM can be grounded in the search results that we obtain from this. So if we were to look at building a AI-powered search application, then let's see how does that come together. But why do we need to build a search application? Who is the user? Everybody is a user who is interacting with that application, which means the providers who are providing the medical assistance, the emergency department, for example. We have the folks who are looking at the billings, for example, medical coder, who needs to understand those billings, the medical codes, and convert them for right billing. We have the personas from the life science stream to do the retrospective analysis of a lot of this data that we're collecting. And the problem is that querying this data is generally very hard. Why is it hard? Because our electronic health records are not meant to be used that way. They have typically manual file explorers. You have to go through a lot of those screens to find the right answer. You have to navigate a lot of systems to find the right answer. And God forbid, if you don't really know that that answer exists, you may not be able to get that answer anytime. And not just that, interacting with these records requires SQL knowledge, for example. Our clinicians now need to understand SQL to write that code to really fetch that data. Not happening, I guess, which results in incomplete results. So we provided the solution to have a search bar on top of all of these results, which is medically tuned. What it means is that this medically tuned LLM that is powering the summaries, it can actually understand the medical acronyms very well. It is no more a keyword search result, but really understanding all of the families that belong to that medical group and giving the result around that. We have an example of a doctor's note that is handwritten, and it is really explaining the details to a patient, giving the prescriptions. The Vertex AI Search Healthcare can actually understand this sheet. It has OCR support, meaning it can do a text search within this sheet, which is handwritten notes. And not just that, we can provide these answers to our generative AI capabilities to really get the questions answered in the natural language. So what does Vertex AI Search does? Essentially, it really looks at all of these different data sources, structured, unstructured, and also the public data. You have PubMed publications, you have the ICD codes, all of that come together to really provide the results when we do any kind of search. Not just that, you have internal data, which is proprietary information within the medical organizations. That data can also be applicable to this search facility. Once we do the search, we can ground the answers of the LLM into that results. But not just that, now we're providing citations also. So this is very high fidelity answers. You can always dive deep into, okay, where is this answer coming from? What is the document that they can refer to? And really you get more trust when LLMs give such kind of answers versus just giving you a summary and not knowing what is the source of that information. So it is really important to have the citations when we are also looking at such a vast amount of data put together. Let's look at the data stack. Yes.
How specifically does Vertex AI search like actually help with that? Because they're able to like understand like different like types of data, but how does it navigate through the problem in EHR specifically with clicking through everything and finding the data that you want?
I do have a data stack where we talk about how do we really bring that together. The essence here is that we standardize the data formats to Firestore. And we have a turnkey solution called a healthcare data engine and healthcare APIs that can help you do that. That is coming in the next slide. The idea here is that these different formats can be put together into the modality specific data stores.
And is this like interoperable? So like if I took
Yes.
like an Epic, a Cerner right here, like it would
Yes.
be interoperable?
Yes, that is the core function of the
Firestore.
healthcare data engine.
Okay, cool. Thank you.
That's what enables the interoperability between different systems and formats and structures. So if you look at the data stack, the first step is to really ingest all of these data sources. These data sources could be FHIR format, lab results in the CSV format, HL7, or maybe scan documents like medical images. They are, there's batch streaming, batch and streaming capabilities. We have BigQuery and we have the Google Cloud Storage to have all of those scanned images stored here. Native solutions for FHIR and HL7 are also available. This is what the healthcare API does. It brings together all of the data in different formats and pulls it together in one layer. Once we have ingested all of this data, we have to harmonize it, meaning that is where the healthcare data engine comes in. We have a data mapper that transforms and maps all of these different formats of data and convert it into the FHIR format. We have the managed pipelines that can help transform and automate the loading and the processing of this data to create a single FHIR store. This Firestore is the standard data set that is queryable and that can be used by uh, the let's say analytical solutions like Looker dashboards, or maybe some kind of search apps or some kind of other UI that you want to build on top of it. But Firestore is the one that is providing you a harmonized longitudinal record for every patient, and that becomes the source of truth for querying the data going forward. On top of it is the processing layer, wherein we have the Vertex AI search capability to search all of this Firestore, and also the MetaLM to really create the summaries out of these results. And the last top layer is the application layer, where you can have your custom widgets applied to it. You can also have Looker dashboards to understand what was the most queried disease or what is the most recommended medications. All of those results can be seen in Looker dashboards and any other analytical tools. We'll go to our next section, and I'll hand it over to Brinda to help us walk through the cloud's Vertex AI offering. Brinda,
Thanks, Megha. Let me share my screen. So I'm going to quickly run through the Vertex AI services, which will be very useful for students like you, researchers, and also enterprises. Going into the top and foremost important part of Vertex AI is the agent builder, and the model garden. And as you know, Vertex AI is a big platform which contains several functionalities. And I want to draw your attention to the agent builder, which kind of helps you build multi-purpose agents. It could be for healthcare, finance. It's a very easy to use tool using which you can build agents in 1 to 3 steps. And then we have model builder. So within the model builder, you can use custom models or pre-trained models like BERT, Gemini, the various versions of Gemini. And then you also have ready to use models from external, third parties. And finally, you've got your model garden, which kind of hosts multitude of models, speech to text, text to speech, a chirp, and etc., and so on and so forth. So moving on, what I want to share here is Google Cloud provides you a no code, low code, and a full coding environment using our platform Vertex. So what we literally do is when we say no code, it's literally zero code. You click a couple of buttons and you're good to go by building your own predictive model on Vertex AI. And when we say low code, for researchers who are fairly familiar with Python but not fully accustomed to Vertex AI, they can go in for a low code approach where they can modify the code at some basic levels or interfacial levels. And then you have a full code wherein full-fledged researchers can go in and code everything from scratch. And I want to show you how Google brings all this AI power together for you. So the entire value chain is what you're seeing here. It starts out with a powerful hypercomputer at the bottom layer, which powers all our Gen AI functionalities. And on top of that, we have a very robust data platform. As Megha shared earlier, there are several ways of capturing healthcare data. So we have this data platform, and above which we have a Vertex AI. And this platform hosts a model garden, model builder, and the agent builder. And above that is our agentic engine, which is the talk of the town now. So later we'll show you how you can build your own agents using agentic engine. And so that's agentic engine for you. And above that are your applications. So these applications can be chatbots, assistants, or any applications that we have already seen at healthcare also in our previous session. And we also have agent space. So agent space is like where different agents interact with each other and they work with high interoperability and seamless connections. So moving on, let's take a quick look at what the Google Agent Engine looks like. So over here, what you see on your left is your client, which integrates with several, different data sources and APIs. So you can integrate with any API that you would like to integrate it with. And then you move into the agent engine space, wherein this agent has its own memory and it has decision making capabilities, basically. So how does a chatbot differentiate with the agent? Right. So agents have decision making capabilities and integrated with several tools. That also is the process right after the decision making. You want to like start off a particular process based on the decisions taken. So that is what this entire thing enables. And at the bottom, what you also see is evaluation. So as you build these agents, you want to constantly evaluate them and you want to make sure that it's running as per its norms and also observe the traces and the logging. So this platform comes in with all these pre-built capabilities, which makes your life very easy when you want to build agents. And what I'm showing you here is you have the freedom of choice at every step of this AI building process to easily manage your data. So on the left, you've got your BigQuery, GCS, so that's your data. And you have the compute layer where you have TPUs, GPUs, everything at your fingertips. And you have frameworks like PyTorch, TensorFlow, which researchers might be interested in. And then you've got your models, Gemini, Imagen, all the very specialized models for images and speech to text, and also external third party models, Hugging Face models. And the final layer is your agents, wherein you can build agents using LangChain, which is also possible within Vertex, and also Vertex AI specific agents and Llama Index to kind of index all the data that you have. And moving on, so here I wanted to draw your attention to the three simple ways of leveraging what we have on Vertex AI. So if you are somebody who wants to train a specific model for genomics data and healthcare, you can go in into your collab enterprise notebooks, and Vertex AI training is something which instantly lets you train on custom data. And you also have Vertex AI experiments, which lets you load managed datasets. So say, for example, you don't have your own datasets. Using this, you will be able to load your own managed datasets. And then tuning. So tuning, there are several ways to tune in this day and age of LLMs. So you can tune your prompts or you can tune your model itself. So you have an array of services for your tuning purpose. And finally, augmentation. So we have kind of matured in this LLM space in this past 1 or 2 years. And by augmentation, we mean that we want to ground the decisions of these LLMs to the data so that we know, for example, if we are searching something, we want to ensure that there's zero hallucination and all the search results coming up is grounded to real world data. So that is what augmentation is doing here. And to give you a full picture of where all this fits in, so this is a unified view of what is going on here. And you have a low code, no code environment right at the top, which we saw right now. And then you have ways to build your custom workflows, which could be using managed data sets if you don't have your own data sets. And you can train your own specialized models here and also deploy seamlessly in few clicks of steps. And what additionally we offer is the MLOps, which is very useful for enterprises because enterprises are usually interested in model monitoring, explainability, and feature stores and model registry. And for those who are familiar with machine learning, these are quite handy. And when you have them offered in a platform, you can move from POC to production in no time. And I also want to bring your attention to this auto ML pipeline and workflow. So, say for example, you want to build a certain model for your specific area, maybe using a genomic data, and you're wondering where to begin. AutoML is a great area to begin with. So, using AutoML, all you need is a data set. So, data set and your understanding of the data set, you set your outcomes that you want the model to do. Maybe predict a certain outcomes in healthcare. And using this AutoML module, you will straight away move into predictions in no time, and all this is possible on Vertex AI. And you'll also be able to set your budgets. So, budget as in every training incurs a certain amount of cost, and AutoML allows you to set your budget, help you choose like the smallest model, most optimized hyperparameters when you train machine learning models. All of that is done like automatically using the AutoML pipeline. And going one step deeper here, I'm just elaborating how this whole pipeline looks like. So on your left, you've got your data, and then AutoML creates your features automatically. That is your analyze step. And then you've got your whole array of models. It's called the model zoo. So you have your linear, logistic, feed forward networks, LLMs, all the kinds of neural networks under the sun is available for you. And the best part is AutoML will pick the model which is appropriate for your data, which is sometimes even beyond what we might expect. We might know a certain model fits the bill, but when you look at a real world deployment, that may not be true. It might incur a lot of cost and you might want to revisit the model, design and all of that. But with AutoML, it's a very good starting point. You'll get to instantaneously know which model fits the bill for your data, and evaluation of the model and deploying everything is done seamlessly for you. So here is a much more deeper picture for those who are interested to use Vertex AI for their own training purposes. So you have your data sources in a CSV, a BigQuery table, or a BigQuery view. All of this is supported for your training purpose. And you can define your columns and your target data. And then you can perform transformations and feature development on the fly. So traditional ML researchers would know this, that feature engineering could take hours of effort to days of effort. But with Vertex AI feature development module, you can develop and transform your features quickly and then train your model based on those features. And at the bottom, you have your model setup workflow, wherein you can set up your model, like pick the model that you want and perform training instantaneously on the data set that has been created. So next, I have some interesting use cases, and feel free to ask me questions around this area. I'm not an expert of genomics data, but here I'm going to show you some of the interesting areas where you can start using this right away. And the first and foremost is, as you can see, so usually the jargons used in genomics are plenty, right? The medical jargons are numerous in nature. And as a researcher, if you want to embark your research journey, you will want to understand multiple papers in the domain, which normally, as a researcher, when I did my PhD, it took me like weeks to months to understand the literature around a certain topic and then consolidate that into a review paper, and then I take it forward to the next step of my research. But with Gen AI, what you can see here is, like, you can see this is a very verbal textual prompt that I've written here, like summarize the key findings for a particular role of APOE gene in Alzheimer disease. And then I provide multiple abstracts at this stage, and using that I can extract what I need from it. I can kind of summarize the relationship of this gene probably with other genes, and this is just a starting point. Like, you can get creative and start creating your own prompts which is more suitable to the research that you're performing. So later on, I'll show you quickly how this can be used on Vertex AI platform to kind of help you perform literature summarization quite efficiently. And the second use case that we have here is a variant interpretation assistance. So this is like an assistance. Imagine this as an assistance while you do your research, which is sitting with you and you are trying to understand like the potential functional significance of a variant RS7412 in the APOE gene. And you're a new student and you're kind of lost with the jargons. And this is exactly what you could ask the LLM to kind of elaborate on. And you can take it to the next level by even posing questions like, how is this significant with the other research papers that you have read? You can bring in all the citations and the links into your prompt, and then the Gen AI tool will be able to assist you as a very good variant interpretation assistance. So let me quickly give you a view of how easy it is to kind of do all of this. So this is pretty much the interface of this Vertex AI, wherein you have multiple functionalities on the left. Let's not get overwhelmed with it. What I'm trying to use here is the prompting within our model garden. So using a prompt, like here I'm writing down in English language that summarize the findings of this gene in Alzheimer's disease. And I've kind of created a hypothetical abstract. So using this abstract, I'm going to prompt this LLM to summarize and explain everything that is related to this gene. And once I write my prompt and click the button, so you can instantly kind of summarize in bullet points or in the variant forms that you need. If you're writing a research paper, probably you want it in a research format. So here is the beginning of this agent, AI assistance, wherein you can see exactly the details of the gene, how significant it is, to the risk factor, and so on and so forth. And you can continue prompting. It's a multi-turn conversation. So this is one of the examples that I wanted to show you. The other kind of assistance which helps you with the variant analysis. So here I'm prompting into saying, explain the potential functional significance of a particular variant in the APOE gene. It's a very specific question that I'm seeking answer for. And here you have like the full details of, it's like your medical dictionary, like a customized AI assistance medical dictionary, you can say, gives you all the details related to this particular topic. And again, you can continue asking your questions and take it in a direction which makes sense for you. So that is the best part of having these assistants. they are not scoped to do just one or two, three activities. They can be a great assistance to kind of help you understand and interpret, which really accelerates research from taking months and days to like few weeks of time. I'll take a pause here. If there are any questions, we'll address them and before we move on.
Well, I give you a query I'm trying to do and see if it just happens to work great. Would that be okay?
Sure. Yeah, sure. Go ahead.
You said.
Yes,
So-
yes, we could. We could.
so I was trying a query, which is what loci are associated with obsessive compulsive disorder?
Didn't catch it.
What loci,
Okay. What?
LOCI,
LOCI. Sorry. Okay.
yeah, are
Okay.
associated with obsessive
Okay.
compulsive disorder? Because there's literally a new data set just out that has 50 of them. So but it's hard to query.
Okay. I need to give you a fun fact on that, but let's do the query first before doing that.
And I like that you have a typo, so
Yeah.
that's even better.
Yeah, like
Don't fix
I
it.
intentionally use them to, it kind of gets through all the typos.
Okay.
Go ahead. Yeah, I hope you can see the screen
Yeah,
well, so able to interpret. Okay, cool. Yeah, just let
it's
me know
cool.
if it makes sense and I'll give you the
It
fun
does.
fact. Yeah.
No, it actually makes sense. Very cool. Thank you.
Okay. The fun fact I wanted to share is, as you know, these LLMs are trained on data, right? Data belonging to a certain time frame. They're all time oriented. So you just mentioned it's a very good question and point actually. You mentioned that a recent data set has been released. So the fun fact is you may not see that reflected if you use the LLM directly, but when you click on this grounding, right, this is a tool which is just being developed. So it may not be fully functional here, but I'm giving you the secret sauce here. So if you click on this grounding, it'll go and look into the web data on all the latest and the greatest out there. So when this is completely, functional and available, you can try it out yourself. Then you'll have the new data set that you mentioned, which got recently released, also appear in your answer once this functionality is used. So that is, yeah, if that makes sense. Yeah.
Thank you. Yeah, it does.
Point to note is LLMs are trained on a specific time frame of data, and if you're looking at recent data like the recent out in the news, you go in for grounding with LLM. So that is the secret there.
So Blinda,
And
very
okay,
quick question. How many models are
yeah,
supported right now on, there was a switch
more
model
than
right now. Just curious, how many models are supported. Go
we
ahead.
have all the external models as well. So inclusive of all of that, several models, right? Like you can see here, these are the foundation models. You can look at the count, it was around 100 over. Uh, so these are the latest and the greatest. And you have Claude, you have Gemma, which is our open source. You have Llama 4. So as you can see, the list goes on. It's 100 over models.
Thank you.
And
DeepSeek also.
yeah, let me know if you want to. Yeah, go ahead.
Oh, just wondering if DeepSeek is also available on the list or no. Open source.
Yes, yes.
Great.
We were told that was also available. Yeah,
Yeah.
here it is.
Thank you. Awesome.
So that is how GCP is differentiated from the rest, as in we don't insist that they use only our models. We would like them to bring all the models into our model garden and then feel free to use anything that is suitable for the customer and enterprise needs. And yeah, so to quickly show you, when on the left panel, maybe when you go in and explore later, it might be of use for you. So you have your collab enterprise that I spoke about. So you can write coding over there. Create prompt is where we wrote our prompts. And prompt gallery, this is an interesting resource. If you don't have a starting point, you can totally use this to start off. Like this is an interesting example of an animal information chatbot, right? So it's to your creativity. You can use it to however you want to. So this is a great place to come and explore later on. And in view of time, let me move on to two more use cases that I wanted to show.
Sorry, I had one more question about the demo.
Yes, go ahead.
Do all of those models in the model garden, do they have that like fine tuning that you've showed for, genomic specific and healthcare related data applied on top of it, or are those two distinct things?
Really good question. So every model, of course, you can fine tune definitely on our Vertex AI, not really on the model garden. The fine tuning process is a separate one. However, so the researchers and the product has picked certain hand-picked models which are best for fine tuning. For example, like when you talk about fine tuning, you're talking about changing the weights at various layers of these models. And it's not good to change certain weights. So that is well known by our, deep mind researchers. So based on that knowledge, we recommend you to fine tune a certain kind of foundational models, maybe a Gemini 1.0, or so that is also available for you on Vertex. So you don't have to run your brain on understanding which fine tuning works for which model. It's all out there, and you have to pick your model and start fine tuning them. Yeah.
So the model provided by Vertex has already been fine tuned on that um, on a
There
like
are
a
also fine-tuned models. Yes, you're right. There are pre-trained models also. And if you feel the assistance is not well versed with your jargons, say you're using a specific healthcare data, which you feel LLM is not there yet, it has to learn more, you can do a fine-tuning. And yeah, later I have a slider on to show you the different kinds of fine-tuning. So you can pick your favorite from there and start your fine-tuning if that is of interest to you. Yeah.
great. Thank you.
Yeah, and I have two more use cases along these lines. So we call them the low-hanging use cases, right? Which means you can straight away go in today and write your prompt like you did just now and start off your, Gen AI journey here. So the two other cases where it's really of use is your hypothesis generation and exploration. So when I did my PhD in finance, I didn't have to go through a lot of hypothesis, but I understand that in the medical world, hypothesis generation could be a task in itself for the new researchers that are onboarding themselves. So here you can really write your prompts to ask the model, like suggest potential biological pathways that might, link to the gene XYZ to type 2 diabetes. And along these lines, you could ask any question and generate your 10 hypotheses. And you can pick, like run through them with your prof or generally, and then pick one or two to kind of take it forward in your research journey. So this is another area that I wanted to show. And yeah, the final one is related to code generation. A quick question: how many of you all write code in the bioinformatics space? Prof, if you could help me. No.
Like
Okay, cool.
quarter of them, yeah.
Cool. So this is really handy for you. I'll show you an example using the prompt. Yeah. So like you can see, you have your assumptions being provided to you. And since the question was around general pathways linking certain gene to type 2 diabetes, so it's kind of brainstorming and providing you of a certain pathway here, pathway 1, pathway 2. So you can replace all of this with your own specific jargons, and you will get a couple of hypotheses that you can make use of in your research. So this was one example. And the other is for those that like to write code using Python. So you can replace this with any language. I'm giving you an example with Python. So I'm specifically asking for a script using BioPython to download FASTA sequence for human gene BRCA type 1. That is a very specific ask. And as you can see, within seconds, you have a starting point. I wouldn't say every code here will always be 100%, just to be fair, but definitely it could take me a couple of minutes or hours to kind of hand code all of this. And but instantly you have a starting point which you can, make use of, edit accordingly. And it also kind of explains what is going on here. So it helps with code documentation, which kind of helps you share your code with others and, socialize it with your profs to make them understand what you're trying to do. And this is again a starting point. You can start asking more questions. Say, I want to add a different data set. And let me know if you want to prompt here again for those who are familiar with this. I'm not too familiar with, the sequences. Let me know if you want me to prompt something over here for the coders. And yeah, so this is your example of code assistance. I'll take a pause here again. If you have any questions, feel free to ask.
There's a question here.
Yes, go ahead. Go ahead.
Hi, I use OMOP a lot, which is the common data model. If I were to
Mhm.
prompt engineer that, would it actually pull codes from a website, or do you already have that internally? It's a
So the
common data
LLM,
model that uses source concept IDs.
yeah, so basically the learning for this LLM is all the data that's available on the internet, right? And then there's a decision and intelligence layer which kind of curates and gives you the most appropriate, answer or code for your question. So as long as it's a model that is existing, you should be able to get the best out of like a consolidated intelligent layer, which brings in all the code together from the GitHub. So GitHub is a training input training data set for the LLMs. So for your case, you should be able to get that code that you want specifically. Yeah,
Okay,
we could
so just
try.
a,
Yeah.
a follow-up question. So if I gave it a website to, let's say, scrape and pull the codes from there, would it be able to do that, or is that too much?
That's a different process. So the
Okay.
vertex search that Megha shared earlier integrates well with websites, structured data, or any types of data. So the way it works is you pump in your website and then you have a chatbot wherein you're asking specific questions, of course, related to the website because you're fully aware of what the websites hold. So that is also possible
Okay.
in that
Thank you.
workflow. Let's move on to the advanced use cases. Uh, yeah, let me see how many of y'all can relate to this, but these are a few advanced text mining use cases within this domain itself. For example, like if you want to improve the identification of certain genomic, entities, and you want to do a NER. So how many of y'all are familiar with named entity recognition, if I may ask?
There are three books here.
Okay, that's cool. So, as you know, NER is a process where you previously I have used BERT and several ways of doing it. Prior to BERT, I've written my own rules to identify these entities. And if it's a medical jargon, I have to run through a lot of rules to identify them. But here with Gen AI, you are able to identify the NERs instantly. You could go back home and try later, like write your prompt to say, this is my text, this is my abstract, give me all the entities related to this particular, maybe a biological topic or any topic. So that is an area where this comes very much in use. And in the worst case, like we had this amazing question where the person asked about the fine tuning. So say for example, this great LLM knows everything, but it's yet to learn a few more things which you think is necessary. You can go ahead and fine tune a base LLM with the specific abstracts and papers so that you don't have to spend hours of effort running through these abstracts. You feed it to the LLM, let it do its job, understand and make sense, and give you the output, which is the entities or whatever the output that you need. So, this is another area for use. And similarly, similar to NER, we usually have relation extraction. So when we look at a knowledge graph, for example, we are looking at entities and how the entities are related amongst each other and related to different, other external entities as well. For example, how drug Z targets pathway W, or there are various numerous relations that are possible, right? So here again, you will be able to discover these relations very quickly. So this kind of saved me a lot of time in my research, which when I started 5 years ago, there was no LLM. I started from scratch trying to figure out my relationships between financial entities. My research was focused on finance. And then here I was 2 years ago, I had to change my entire research direction because I had a LLM which could do that instantaneously. So I used a LLM to enhance my relation extraction. So that is your second example. And the third is like domain specific literature classification. So as you know, for researchers, we are interested in different literature that happens under various categories, and you may want to write a review paper on how that looks like on your research area, and this assistance will help you do that in a couple of days. And this also took me, the very first review paper took me a couple of months to read every paper, understand the 30 literature, consolidate that myself, like categorize them across categories. But here, if you are ready to embrace LLM, you can start using LLM to give you that info, the exact info, and you will be able to get your review done in like few days. So moving on, three more interesting things to do, like you can create your reports taking it a step further, you can create your reports, summarize certain variants using a similar approach. And you can also create specific text formats. Like you want to create a, you've written your research paper, but you want to kind of fine tune it to the conference, and you want to take help of a LLM, which I think usually we have some writers, research writers helping us in universities. But here you can use your LLM as a friend and get that sorted. And say, for example, a really great question right now was using the Vertex search. How do you imbibe a website? So here, this is how you do it. You can create your own Q&A system. Say, for example, a researcher's life is like 5 years, right? 5 years or more of research. So as you progress in this journey, you have read multiple information out there in the internet. You bring in all your research papers, white papers, the data into your own, LLM agent, and it becomes your Q&A. So when you are wondering what next with your research or anything, you can write your own Q&As, make it your really good research AI friend, and start, progressing your research journey there. So here is an example of how you use like genomics data. So I've created some hypothetical data set here. I'm sure you would understand this a lot better, the data itself. And we are kind of identifying topics which are common across this data. So we are doing a topic modeling. So I'll share this code later with you. So the way it works is it kind of identifies the topics of interest and you get a score. For example, in document 1, the tumor was like zero point 0.3 confidence. You get a score of, every topic that is of relevance in the data that you provided. So this is an example that I wanted to show. And the second is text mining itself. So wherein you again have a genomic data set and you're trying to look at like a word cloud, right? What is the most important, significant area in this entire data set? Maybe you want to use that to progress your research or progress your projects. So this is another example where you can give a number of data related to genomics and identify the topics that are related using a word cloud. And taking it a step further, you can also perform clustering. So clustering means which papers are related to each other and which topics are related to each other. So feel free to have a look at these later. So here we've got like 10 plus clusters from the tiny data set that we have provided. So when you provide a larger data set, you'll have, clusters accordingly. And yeah, so that was the details. And I wanted to quickly show you the fine tuning. This is the last topic that I have. And so we had a lot of interesting questions on how do you fine tune. That's like very important for us to know. So what you see here on the left, there are 4 ways to do it to customize an LLM. The first and foremost is your prompt design. You can vary your prompt and use 1 or 10 examples to give examples to this LLM and make the LLM understand what you need and tune it at the prompt level. And then you have RAG and long context, wherein you take it a step further to kind of tune based on data. And then you have supervised tuning, where, like we discussed last time, we have 100 over examples, and we can choose our models like Gemini 1.5 Flash and Gemini 2.0 Flash. You can pick your models and fine tune this very specific to healthcare. And finally, we have distillation, which is for those who want to deploy this in enterprises. So here are like 4 ways that you could explore. Do reach out to us if you would like to, go ahead with any one of those for your work. Yeah, that's the end from my side. Thank you. Let me know if you have any questions. We could take 1 or 2.
Uh, Thank you for the presentation. I was just wondering, are there any potentials for hallucinations in the LLM?
Really good question. So generally, hallucination is a feature of LLM. Like LLM is used for creative writing and for creative purposes. So we see hallucination as a feature. But in healthcare and finance, we want zero hallucination, right? So that's where grounding comes into play. So with grounding and the approaches that I showed, you can reduce your hallucination to zero. Like in your prompt, you can say there's a feature called temperature. So when you set the temperature very low, it rarely hallucinates. So that feature is in your control to use it when you want. Like if you want to brainstorm hypothesis for your research, you wanted to get creative, you can increase the temperature. So you get a little bit of that, not hallucination, but a logical, creative answer. But if you want zero creativity, like healthcare, like no nonsense, I want exactly to the point, then you have it set to zero. Then you have like no hallucination happening. I hope that answers your question. Yeah.
Yeah, thank you.
So
Right, no more questions? Yes, we have one more question.
In the beginning, you identified data access between providers as one of the main problems in healthcare today. How does this solve this problem? Because different healthcare providers will still not have access to the patient files of other healthcare providers, right?
Right. So what Brinda just shared with you is just looking at the LLMs and fine-tuning those. These are the concepts that we apply towards building out the healthcare application that we initially spoke about. What it means is that, and Brinda, please feel free to jump in. The point here
Yeah,
is
I'll
that
add it after you, Megha. Yeah.
the point here is that we help accessibility through the search engine, and that search engine gets the data from all of these different data sources. You fine tune the model, for example, MedLM, we have it already fine tuned for you. That is looking at all of the research publications, or it can also look at the internal data that we have in place. We have different systems to address that problem of different structures, different systems, different formats. We apply that healthcare data engine to re-standardize all of those into FHIR format so that it becomes more queryable from a single search application.
But does that mean that a healthcare provider also has access to previous patient files of a different healthcare provider?
Just to add in here, that's a really good question. It's very relevant in Singapore's context, at least. So, what is happening here is, like you rightly pointed out, we have different healthcare providers running their own way in terms of formats. So, it has to come in from a government level. Like here, we have MOH, which is Ministry of Health. So, which kind of insists that here is the platform, provider 1, 2, 3, here is the platform. It could be powered by Google, or, technically it's possible to solve the formatting issue, like Megha shared. But this has to come down at a government level to say, hey, please follow this. You could have any X and Y format, but make sure to bring it to a common format and then allow us to access your data so that we can have that longitudinal view. So this is something very relevant. As of last week, we were like discussing with some officials around how do we do this as a country as such.
Right.
So
And
yeah,
then
great
2 weeks
question.
ago, New Zealand government has launched a contract for about some millions of dollars to really bring together all of the EHR data across the country, across different systems, so that it is accessible to all of the hospitals to start with. So they are really bringing it together. And again, they specifically called out that the standard formats will be FHIR formats or DICOM. Yeah.
do we have more slides?
We have
Okay,
one
go ahead.
quick
Yeah.
sections, and
All right.
I'll go through it real quick in interest of time. What are AI agents? We often see, what we have seen so far is that we have LLMs which are able to answer the questions based on the training data that they have. They're answering based on the passive prompts that the user is providing. And that's all. That's where it ends. But agents are now taking it step forward, meaning if we have more complex tasks to accomplish, which can be essentially broken down into subtasks, that is when agents come into picture. What it means is that it has a planning module, meaning it can plan to break down that bigger task, complex task into smaller subtasks. It has tools to achieve those different kind of tasks. And then it has memory to understand the context. It retains small memory, larger memory, meaning it understands the whole context of the conversation that you've had so far and what user really wants to do. We'll see some examples on this. But in a sense, AI agents are the autonomous agents that can leverage these three kind of, I would not say tools, but three workflows to achieve an outcome on behalf of a user. What it means is, let's say we have a typical LLM workflow. User gives a question to an LLM in as a prompt, and let's say if I have a question, what is the capital of France? I get an answer. The capital of France is Paris. Very simple workflow using LLM. I ask the question, when is my child's spring break so we can plan a trip to France? It fails. Why? Because it doesn't have access to my personal data yet. It is trained on the data that is already available outside. So what I do is that now I give it access, give it API access to my calendar, and I instruct the LLM to go search the APIs, look the data that I've provided before you answer the questions. And then I ask the same question: which week is the spring break for my kids to plan a trip to France? It gives me the answer, April 21st, 25. It can see a calendar block, or it can see that has been the school calendar is being integrated, and it gives me the answer. Now I go ahead and ask the next question: what is the weather in France during that week? But LLM knows that it needs to search what I give. It needs to go search my calendar and answer the question I asked. But why I gave access to my calendar, it doesn't have that answer, so it fails. So now I give it access to the weather app. I ask the question again and I get the right answer. What are we doing now at this point? We're breaking down a bigger problem statement into some problem statements, and we're giving it more tools to access the right information and get the answer. So refined workflow will be that now can you go ahead and block my calendar for this week so that we can plan a trip. It now goes, it has access to my calendar. It generates an action on behalf of me and it blocks my calendar, and we go from there. So essentially the key features for AI agent is that it is autonomous, it is goal oriented, it breaks down the complex tasks, and it also refines over time. It takes the feedback from me and it refines its answers. If you were to look at it, what the diagram shows is that it can have multiple tools in the form of APIs or functions or a search element or a database. You can give as many tools you want. It can also access public information. It can access internal proprietary information. So these are the tool sets that an agent can leverage to answer a question. It has a memory of its own so that it understands what the question is, what the context is, and it can break down that bigger complex problem statement into smaller ones and use the right tools for the right tasks. We are now heading into the multi-agent phase, wherein we have a number of these agents, and this is really the most advanced use case. The idea here is that we now create multiple agents, each agent specialized in doing certain tasks. And the way these agents really interact with each other is agent-to-agent protocol. This was released by Google 2 months ago, so feel free to dive deep into those, and you'll see much more details on multi-agents. So we have these use cases. I'll leave it for you to look over those, really getting to the resource section and how to really get started now. First and foremost, understand your journey. We were just very recently in the age of classic AI, wherein we were looking at these supervised learning, unsupervised learning algorithms, clustering algorithms, using labeled and unlabeled data. We are now moving towards optimizing the processes that originally existed, meaning looking at LLMs, looking at the prompt engineering to fine-tune those LLMs, then looking at RAG. I want to pause here, by the way. Some of the several questions that came up today was that, hey, we have this LLM, can we provide a website as a source? Or how can we really fine tune those LLMs to look at the recent data or the real data, realistic data, real-time data? That is when the RAG comes into picture, and managed RAG is what Vertex AI search is. It is, what it means is that RAG, why do LLMs fail? Let me start there. LLMs fail because they only have limited knowledge based on the information they've been trained upon. If the information is now 2 years outdated, then you miss out the information for the last 2 years. Or another way could be that LLM is not able to access your internal proprietary data. Every medical organization have proprietary information, research, patients' records. It's not able to access those. So then RAG comes into picture. You can give the proprietary data, or you can provide some latest information so that the LLM now answers based on the latest data that it has access to. Patient information keeps updating. There are more prescriptions coming in. LLMs will have access to all of that real-time data to give you the answers. That is when the RAG comes into picture. With RAG, the problem is that now we have complex, bigger tasks to accomplish. So we break down those tasks and we create agents out of those. And that is when we transform the experience of the end user. These agents conduct the activities on behalf of the user, and they learn and they self-refine themselves. Understand this journey where you are. Identify low-hanging fruits, meaning lowest cost use case but highest impact. Example, automating some administrative stuff using agents, or it could also be applying the search based on the numerous data sets that we have for medical history for a patient. And it all starts with data. So we have to start working backwards and start cleaning up the data, fine tune our models, apply RAG, apply agents, and achieve the end goal. We have resources for you to get started. Feel free to take those. And that's all we have for today. Thank you.
Great presentation. Thank you, Megha and Brinda.